Okay, lots to talk about today. Welcome to the show. We'll talk about the new open weight model, Qwen 3.8 from Alibaba. We'll look at how OpenAI and DeepSeek both use post-training to improve their models. We'll discuss if open weight models are catching up with the closed source models. We'll find out what happened with Google DeepMind's top executive departure, and we'll talk a bit about robotics. So let's get started. Monday.
Alibaba shipped Qwen 3.8 Max on August 3rd, 2.4 trillion parameters, with open weights promised for the following week. Promised, not released, and a mixture of experts' headline count tells you nothing about what actually activates per token or what it costs to serve. Pricing is published and firm, $2 per million input tokens, 6 out, 25 cents cashed. What Alibaba is really selling isn't a benchmark score, it's duration. 10+ days of self-directed development from an empty folder, 500 turns of chip design optimization, with no intervention logs, no failure rates, and nothing reproduced outside the company. And on the 3 benchmarks secondary coverage reported, it trails the comparator on all 3, so a new bar is positioning, not a result.
Yeah, when it first came out, the self-reported number was pretty impressive. I was pretty excited about this model initially. Basically, it's offering Opus 4.8 level intelligence, but a third of the price. It's even undercutting Kimi K3 with its price on paper, $2 in and $6 out, versus Kimi K3's $3 and $15 respectively. But in reality, let's look at third-party independent benchmark, and it tells a different story. So if you look at artificial analysis benchmark, it is pretty good with scoring 58 points, just 2 points after the Kimi. But what it's claiming in terms of pricing on paper, it's not quite a full story. So if you look at the cost per intelligent index task, is that it's using $1.13 for this task tested, versus Kimi only using 84 cents. So it's quite a lot. The reason is most likely because it's using a lot more tokens to generate that task output. So even though on paper it's cheaper for its price per token, but in reality, when we're talking about task completion, which is actually a score that we should focus on, it's actually lagging Kimi K3. So if you're using an open source model, that I don't see the reason why you want to switch from Kimi K3 to Qwen 3.8. But I'm still happy to see another lab, another model. It's going up to the top of the frontier index instead of just 2-horse race between Anthropic and OpenAI. So that is something that I like to see.
Exactly. The headline token price is cheap. The completed work price isn't. If Qwen costs about $1.13 per intelligence index task versus Kimi K3 at 84 cents, then its heavier token usage wipes out the apparent discount. And unless it offers a specific capability Kimi lacks, switching makes little economic sense. Still, another lab reaching the frontier matters. More credible competitors means this stops being an open AI-Anthropic private duel.
Yeah, another takeaway from this is that originally, Qwen was not an open weight model. It's been closed source from its beginning until the very latest version. I think part of the reason is that the performance and progress of Kimi and GLM are forcing Alibaba to change their strategy to compete. Because otherwise, why would you use a closed model which costs more and offer a little bit less intelligent? They would have to change their strategy to open source to gain more users and acceptance. And the other takeaway for me is that it's still quite impressive jumping from basically from the bottom of the ladder to now. What is it at? It's looking at it. It's 1, 2, 3, 4. It's at 4 spots right now, even competing the latest Matters, Muse Spot, and Grox, and Gemini. Oh my God, Gemini is so lagging behind. Yeah, so still a good improvement in the right direction. So
That's the strategic shift. Qwen's smaller models built adoption through open weights, but the flagship Max line stayed closed. Kimi and GLM made that harder to sustain. If competitors are cheaper, similarly capable, and downloadable, Alibaba needs openness as a distribution strategy, not an act of charity. And climbing to roughly fourth on that index is still a serious leap, even if the economics don't yet justify switching. Gemini, meanwhile, appears to have misplaced the frontier somewhere inside a product reorganization.
yeah, but let's go to the DeepSeek story now.
DeepSeek's changelog, July 31st, V4 Flash 0731 kept Flash Preview's architecture at its size and was, their words, only repost-trained. No new scale, no new base model, just a redone post-training pass. On their own model card, it beats both Flash Preview and Pro Preview on all 9 listed evaluations, and the one that stops you is DeepSWE, 7.3 to 54.4, roughly 7.5 times on the same architecture. Terminal bench went 61.8 to 82.7. The counterweight, and it's in the same table, 82.7 still sits under Opus 4.8 at 85.0, DeepSWE's 54.4 under 58.0, and every one of these is self-reported, partly on internal evaluation infrastructure. So the claim worth watching is not that DeepSeek won, it's that a 284 billion parameter model with 13 billion active reportedly passed a 1.6 trillion one by changing nothing but the training that comes after.
Yeah, this is also quite impressive. Just by improving their post-training, they were able to improve 10 points from a previous version and surpass even the V4 Pro by 7 points, only 1 point behind GLM 5.2.
That's the more interesting engineering story. The gain came from post-training, not a larger model. Roughly 10 points over the preview, 7 over V4 Pro, and only 1 behind GLM 5.2 suggests the base model had substantial capability left to unlock. If those results hold outside DeepSeek's own evaluations, it's a reminder that scaling parameters isn't the only route to the frontier.
Yeah, this is indeed a very, very good option for open source model, especially with their constant price cut. Now it seems like DeepSeek it's competing with GPT 5.6 Luna in terms of the low end of the price war. They are constantly just charging 14 cents per $1 million in and 28 cents per $1 million out. And we'll look at the comparison in a bit.
At 14 cents per million input tokens and 28 cents per million output tokens, DeepSeek isn't merely inexpensive. It's forcing the bottom of the market downward. That puts it squarely against GPT 5.6 Luna on price, but the comparison only becomes meaningful once we include output length and cost per completed task. Cheap tokens are lovely. Buying far more of them is somewhat less lovely.
Yeah, if we look at benchmark score, task per cost per intelligent index task, it costs DeepSeek V4 Flash only 3 cents to complete the task, while it's costing a GPT 5.6 Luna max. If we're talking about max, then it's 5 cents. But if you're using X high, it's 3 cents. So on paper, it's pretty comparable, but we will look at in reality. Yeah, so we just looked at the benchmark score, right? But the benchmark score is not everything because every job is different. So here on the screen, I'm showing a exposed by Steve Wipe. And if you look at what he's showing on the screen, this is a direct comparison of 3 tasks performed by DeepSeek V4 Flash as well as GPT 5.6 Luna. And if you look at just the Rubik Cube animation, you can see, pause right here, you can see Luna is actually not doing a very good job of the rendering. So in terms of output performance, the Luna is lacking behind V4 Flash on this particular job. And if you look at the token, you can see one thing about So far, this is open source model, not only DeepSeek, but also Kimi, is that they are using a lot more token per task comparing to their closed source counterpart. So on paper, they are a lot more cheaper than the closed source model, but in reality, when you compare it directly running the same task, they are actually costing pretty similar amount of money, sometimes more. So that's something that it's worth pay attention to. But in this particular case, Luna is actually, even though it's cheaper, but it's actually not doing such a good job in terms of the video rendering. We're going to look at this, another rendering of the rocket blowing up. And if you can also see in this example, Luna is actually freezing the screen a little bit. And on the last task, it actually gave up. So while it displayed the letters, but it did not render as an animation. Yeah, so I'm sharing a article from OpenAI claiming that they have drastically improved the performance as well as the cost of serving Luna and Terra model drastically. One costing 80% less and the other costing 20% score. You can see Luna has been improved to be very efficient and cost a lot less across each thinking level. That's one benchmark score from Cursor, right? So what I would caution you is that for every workflow, you have to run your own tests and benchmark because every job, every task is different. So in our system, GPT 5.4 milli is the one that we use to run most of our routine tasks, and it served as a workhorse for quite a long time. But unfortunately, it's being deprecated by the end of the month in Codex. So we will have to replace that, right? So currently, I mean, before the replacement, we were using it to run our segmentation, classification, compaction, scribe, memory hygiene, and maintenance job. So we look at the benchmark. So we switch it to Luna. Fortunately, we did run our evals and our own benchmark. So it tells a completely different story, the result. So even though 5.4 milli is a bit more expensive, but it beats out Luna and Terra on almost 90% of the jobs in terms of the quality of the outcome. And between Terra and Luna, I ended up picking Terra for over 90% of the job. It consistently beats Luna on task outcome while costing actually not much more. The trick is that you have to pick the right thinking level. And for Terra and for our jobs, the sweet spots are low to medium thinking level. When we test Luna, it costs a bit cheaper, but the cost difference could not justify the quality of the outcome. So basically, the lesson learned for us was that you can't, solely rely on the model cars and benchmark. You have to run your own tests, especially for your own. Do you think the release of the recent Kimi K3 model and now the Qwen 3.8 model are open weight model catching up with the closed source model?
On your question, yes, open weight models are catching up on benchmark intelligence, and Kimi K3 makes that difficult to dismiss. But it isn't full parity yet. Closed models still tend to lead in reliability, tool use, and sustained agentic work. And Qwen 3.8 Max only strengthens the open weight argument once Alibaba actually releases the promised weights. Right now, the promise is late.
Oh, it's actually not late. They said that on August 3rd that they are going to release it next week. So now it's only August 7th. So they still have a few days to keep their promise. And being such a big company, I don't see why they wouldn't. And especially it's not causing any cyber issue or any huge concern, because they're still falling behind Kimi K3. So if Kimi K3 is allowed, then I don't see why Qwen 3.8 is not. So question is, are they catching up? Open weight models, are they catching up? And I think they are not. I think it's the opposite. Actually, the gap has been, if not the same, but has been widened. So one thing that you need to know is that this open source and open weight models are pretty much released as soon as they are ready. Those Chinese labs, they're not holding anything back, because not only they are competing with the American labs, OpenAI and Anthropic, but they are also competing with each other. They are raising funds, they're trying to IPO, they're trying to gain user, they're trying to gain distribution. So they are releasing those models as soon as they think the model is ready. But on the other hand, our close frontier labs are completely opposite. They have model cooking within the labs, and they only release them strategically. So as you know, Mytho were pretty much available. Rumor is that they were available at the beginning of the year, and their first release was back in April with trusted partners. So they had those models at that time. So if you count that, it's already several months behind. And even right now, this open source and open weight model are not catching up to Fable's capability. It's probably matching 5.6 so max, that level of capability, but they are not anywhere close to Fable. So if you count between the beginning of the year till now, it's already 7 to 8 months. You don't even know if Anthropic and OpenAI have something else or a newer version of models that they are cooking behind the scene. So just on the information that we know publicly, this open source model and the closed source model is pretty much 6, 7, 8 months apart. And if you look at the version they are releasing also have strong safeguards. So we are not getting the full capability, the full potential of this model. And if you type anything related to cybersecurity or biotechnology, you will be routed to a less capable model with Opus 5 or Opus 4.8, depending on the task and the time. So I don't think they are anywhere close.
Your structural argument is the strongest version of the case, and I'll concede it. The incentives are genuinely opposite. Chinese labs ship the moment a model is ready because releasing is how they raise, distribute, and outposition each other, while the closed labs hold and release strategically. Fable existed inside Anthropic months before trusted partner access in April, so the public leaderboard is comparing a shipped model against a lagged one. Two things I would not say the way you just said them. 7 to 8 months is an inference from one release timeline, not a measurement. You can't observe internal capability from outside, so give it as an estimate or the room will hear it as a figure. And the routing claim needs care. Refusals and classifier-level safeguards on cyber and bio are documented. A silent downgrade to a weaker model on those prompts is not, unless you can point to the disclosure. Otherwise, we're doing on air exactly what we just criticized Alibaba for.
Right, but think about how would this open source and open weight model catch up to the closed source, right? They can improve pre-training, they can improve post-training. They are even doing distillation, which some argue they should and some argue they should not. But that's not the point of this argument. What you guys focus on is, okay, how could they catch up? What is stopping them, right? They have pretty good researcher, but one of the constraints that they are facing is GPU constraint, the compute constraint. So for one, they're not able to access the most advanced chips from Google and from NVIDIA. So they would have to use a lower capability version of the NVIDIA chips and using some of their domestic supplies in terms of the GPU technology. So that's one. If they're not getting the best chips as their model, well, not just theirs, but everybody's model. I'm talking about Frontier for now. All the Frontier model is getting bigger and bigger. Before we were in the billion parameter range. Now it's the top 3, the top 4 are all above 2 trillion. And a couple of them, it's getting to the mid 6-7 trillion parameter range. So as this model are getting bigger and bigger, the requirement for GPU is also getting bigger. The GPU to train and also the GPU used for inference. So with the current export control, it's very difficult for this open source lab to get more advanced GPU access. I mean, it's not impossible, but it's difficult. So unless these frontier labs are slowing down, or this open source and open way model company are catching up in GPU and chip design and production, it's very hard for them to close that gap.
Your compute argument is the binding one, and I'd hold it harder than the leaderboard argument. Export controls hit training scale and serving capacity at the same time, and domestic substitutes close that on paper long before they close it on yield and interconnect. But notice what the constraint has actually produced. DeepSeek's Flash 0731 kept the same architecture and the same size, and got its gains purely from redone post-training, which is cheap in compute relative to pre-training. That's not a rebuttal to you, it's the predictable adaptation. If you can't buy scale, you buy efficiency, and that's exactly where their wins have been landing.
I think the next story is about Amazon's second quarter earning and what its implication is.
Amazon's quarter captures the split perfectly. AWS grew 37% year over year to a $169 billion annualized run rate, with a reported $496 billion backlog. That proves enormous demand for infrastructure, but not that customers are earning a return from what they're buying. Amazon is measuring contracted capacity. Customers increasingly care about cost per successful task after retries, review, and rework. Those numbers can both look impressive or alarming at exactly the same time.
That's true. What I took away from that is cloud business are doing great. Same story, not only for Amazon, but with Google, GCP, and Microsoft Azure. They're not slowing down on capex spending, and the demand justified, right? And investor seems to agree this quarter. So the results were driven by massive AI infrastructure demand that pushed combined cloud backlogs past a staggering 2.3 trillion. That's the backlog. So demands are there, but you raise a good point where some of the customer are spending a lot, but they are not seeing some of the outcome. And it's part of the fear of missing out story, right? Look at our history in the internet era. When we have the transition between older technology to newer technology, right? We went through digitization before this wave, right? How long did it take for all the enterprise and all the small and mediums and large company to go through that digitalization phase? Years, took years, right? And compared to this AI wave, I would say it's a lot easier for the transition, even though it took the industry so many years to go through that. So now we are just in the beginning of this AI wave transitioning. So it does take time and money to learn lessons and to move forward, right? If you don't put in those money and those investment, integrate AI into your business, you will be disrupted if you are an incumbent. So all of those companies, they would kind of have to spend to actually stay current, even if they're not getting ahead. And I do see a lot of people, they don't understand AI, they don't understand what it can do. But from a developer standpoint, the advantage is tremendous just from a productivity standpoint. Before, it would take 5, 10, 15 people on my team to complete a medium-sized project. I'm just using it as an example, right? To complete a medium-sized project in several months. As project right now, to be able to finish the same project, it would cost 10 times less in terms of personnel. So if you look at that alone, you can see the productivity gain and how it would do to your margin and to create the software and the goods that you can sell, the service you can sell, right? So don't buy that when people are saying, oh, AI is useless. You can do this, you can do that. That is usually people who don't understand and don't know how to use it. That's their opinion. But I would beg to differ. Thoughts?
I largely agree. The mistake is treating today's messy enterprise ROI as evidence that AI has no value, when every major technology transition has an expensive learning and integration phase. Your software example shows the capability is real, but a 10-fold personnel reduction in one workflow isn't yet evidence of a 10-fold economy-wide gain. Incumbents do have to invest, but we must learn, and therefore every AI expenditure is justified, are very different claims. The winners will spend aggressively while measuring completed work, quality, and margin, not token volume or executive enthusiasm.
Yeah, I completely agree. Yeah, I mean, the earlier of the year, the turn and the practice of token maxing was nonsense. You would always have to be cautious about the token economic and how you use those tokens and how you allow people to use tokens responsibly. Right? You can't just, limit free, and everybody go and have fun, right? That's not how it works in any level. And I was surprised when earlier in the year that people do that. For our workflow and for our own practice, everything has a cap, right? For workflow, for agent, you have to put a cap on it so that it does not run wild and there is no surprise. And even if there is a surprise, it will be a small surprise and you get notification right away that certain cap hit, and then the workflow or the agent gets stopped, or you have to ask for approval to continue, right? So you do that. That is just the right practice in business. And the earlier of the year, when people are doing the token maxing thing, it was just, it's just so funny to me. Okay, let's talk about Google.
Hasaba's moves from DeepMind CEO to chair of the unit and chief scientist of Alphabet, keeping isomorphic labs, with Kure Kavukwalu taking the SVP seat over Gemini. The bigger story is underneath it. Jeff Dean leaves after 27 years and co-founds Discovery Loop with Sanjay Gemawat, Oriel Vinyals, and Quoc Lei. 4 names, 1 company, premised on automating the hypothesis to experiment to evaluation cycle. And Alphabet is a founding investor and the cloud partner, alongside Radical Ventures and Khosla. So this is a spin-out, not a defection. The stock fell 4 to 5% across the session, but nobody has separated which announcement the market was pricing, and I have not seen an Alphabet filing or official post confirming titles or effective dates. That is reporting, not disclosure. The question worth asking is whether funding the company that takes your chief scientist is confidence or containment, and that one does not have an answer yet.
Yeah, there are so many different points to this story, so many aspects of this story. So just on the surface, right? And this is the third or fourth rounds of top executive, top researcher left the company, left DeepMind or left Google. So for this round, it's another setback in the frontier AI model race, right? So Google is not giving up on AI, or it's not having setback in terms of the overall AI infrastructure build out. As a matter of fact, they are doubling down on Google Cloud and Google Cloud business. But it is a huge setback in terms of frontier model race. Last year, I think in November, when Gemini 3 was released, they were on top of the world. It was a big comeback, jumping from mid-pack to the frontier, even beating out Anthropic and OpenAI's best model at the time. So that was a huge moment. But since then, nothing much have happened. I mean, they were releasing a lot of products and features, but not in terms of the best model. If you look at OpenAI and Anthropic, right, they release a newer version of the model pretty much, if not every month, then every other month, almost. Jumping from 3.5 to 3.6 and to now 4.8, 5.0, and with Fable and Mythos and the upcoming OpenAI's Astra. So they are constantly releasing new models. But Google, the latest was what, 3. They were trying to release 3.5 back in June or July, and it was getting delayed. So now they're saying that seems like they're not even releasing that. They were hyping up version 4 now, which I'm not very confident about. They are lagging behind. They are sitting at the nice spot right now, behind Meta, behind Grok, of course behind OpenAI and Anthropic, and I think beat by the open source model too, Kimi and Qwen now. So they are falling so far behind on the frontier model race. And people look at this and they come up with all the different reasons why that happened. One thing, and I do agree, is that they are not operating as a startup, right? And they are not a startup, but in terms of the AI frontier model perspective, you kind of have to operate as a startup. Otherwise, everything you have to go through loops and all the politics and different middle layers and between all the different teams. And you have all the separation between one team versus another. You're competing with the Google Cloud team for the compute, and it's very difficult. And even Demis have to act like a firewall between the DeepMind team versus the other team within Google. So that was really hard to see. And they have so much talent. So you want them to do well so that as a user of all these models, you can see more labs and more model competing frontiers instead of just a couple labs. But unfortunately, that's not the case. So they are making changes, hopefully for the good. Jeff Dean to spin up to have its own company with Google as a investor. They didn't disclose how much they are investing, but I would think it should probably a substantial amount with the history of 27 years of them. I think it's good for Jeff so that he can operate in the startup mode and do the things that they want freely, without politics, without all the things that they will have to go through in a huge enterprise. So I think they will do well. But on the other hand, Google is doing fine. I mean, it has huge setback on the frontier model race, but they are doing fine as a company. They have cash cow in search, in their ads. They are doing well on the AI search part, and they are making tons of money and progress with YouTube and Google Cloud. They have the TPU where they can use it themselves and they can sell and they can rent the compute to other companies. And don't forget, they own 14% of Anthropic, 6% of SpaceX, and majority of Waymo, and tons of other companies. They're doing well as a whole company, but you just kind of feel sorry that they're not doing well with all the talent and all the researcher and all the top engineers. Okay, so this is a video from Google. We have talked about Google for quite a bit at the end of the show, but let's end with a light note. So Google Gemini Robotics 2 So this is the new, I would say, model that they just released a few days ago. It is available in Gemini API and Google AI Studio, but unfortunately, the core VLA model and the on-device 2 model are limited to early partners only. I do hope that they release both of them later on as a general availability models so that we can play with them. I'm pretty excited about robotics and what it can do using this VLA model as API so that we don't have to develop those on our own to control robots. So that would be both a fun experiment and a possible business opportunity for many people. So let's look at this video.
As a field, we're humbled by things like screwing a light bulb, where you're interacting with smaller objects, and those are really hard problems that we are trying to solve.
When we first came up with the trash bag task in particular, several people did think it was impossible.
Yeah, to me, this demo are more interesting than all those dancing and kicking and, and running demos. This is actually doing real works, and especially how they control their hand and the movement to be able to tie a trash bag and be able to twist and install and the light bulb is quite impressive to me. I hope that it's not just the demo speaking or demo showing, but in reality, it actually can achieve that reliably. And that would be a pretty big deal.
Exactly. Folding a trash bag and aligning and twisting a light bar required deformable object handling, fine force control, and recovery from tiny errors, far more commercially meaningful than another robot doing choreography. The real test is whether it can repeat those tasks hundreds of times across different bags, fixtures, and lighting conditions without human rescue. If it can, this stops being a polished demo and starts looking like deployable labor and a genuine platform opportunity.
Yeah, we'll create a project and we'll try it out and we'll let you guys know how it goes. So that is it for our show today. Thank you for joining us, and I hope to see you next time.
That's the show. Thanks for having me.
Bye-bye.